So, as you know, myopia is the most common ocular disorder and is the leading cause of visual impairment in children. According to a Brian Norton study, we have 1.9 billion people myope and 70 million of them with high myopia in 2010. But this number are going to increase dramatically over the next years. So we are talking about almost the half population of the world myope, and this is common to almost all parts of the world. This famous chart tells us and shows us clearly the increase of myopes between 2000 and 2050 in projection. So, what are the risk factors? So, as you know, the family history is one of those. So, when one or both biological parents are myopes, there is a high possibility that the child is going to be myope. Refraction at 8 years or before, if the patient reached already the metropia, at 8 is highly possible that he's going to be myope. The time that children spend indoor is a risk factor for the myopia development. And ethnicity, as you know, Asian has the biggest prevalence of eye myopia. Why is it important to correct myopia? First of all, because we want to prevent severe eye problems, such as retinal detachment or myopia, retinopathy. So, as you can see, there is a high correlation between eye myopia and severe eye problems. You want to improve the quality of life to decrease the spectacle dependency of the patient, which is clear. And for the one of you that want to keep the patient until you can fix the myopia, it's good to keep the myopia low because you have more option to treat them. What are the current methods to control myopia? First of all, we need a change of behavior and awareness. So decreasing the time indoor and increasing the time outdoor, for sure. Then there's a pharmaceutical way of controlling this by means of atropine with some side effects. And then optical way of controlling myopia with special eyeglasses. And here you can see how beautiful is the Osiris image on a Stellex, or I think it's a Stellex glass. Basically, by focusing the central part of the glass or spectacle in focus on the retina, and the peripheral part slightly myopic. This is somehow, even if the onset of myopia is not clear yet, it looks like this way of wearing glasses prevents the myopia progression. And the same on the corneal plane by means of orthokeratology or with multifocal contact lenses, like the one here implanted used from Indiana University in this study. This is the progression rate, the axial length change in myopes and normal eyes in two populations. One is in the Bay Area in San Francisco, and the other one in Singapore. And you can see how the change rate in axial length is different between the two groups. And this is how the, I think is the MySight lens worked in this case. So a group of myopes from the baseline starts to behave in eye growth as a normal group. So it looks like this kind of way of controlling the myopia is actually working. So now let's go to the diagnostic part. It's clear that is crucial to have early screening and evaluation of myopia in children at risk of developing myopia, who have already developed myopia, and to check on the longitudinal evaluation how myopia is proceeding, how it's going. So we want a device able to do a reliable refraction, a good axial measurement, axial length measurement, as myopia is somehow related to the periphery of the cornea. We want to perform off-axis measurement, and according to the latest studies, it looks like myopia onset and also myopia progression might be related to microfluctuation of accommodation. So we need to understand how accommodation works. So the intersection of all these points is where we have to dig. So this one is the identikit of our device. We want a device that is able to measure the axial length between 14 and 40 millimeters. We want a reliable refraction in this range, and we need up to 30 degrees peripheral refraction. So what is the big problem with that? Would you feel comfortable in using an autoref or even an Aberrometry on with a device with children? No. This one is the Ciuffetta, Hug and Rosenfield model of coupling between accommodation and convergence, and you can. Can I have the microphone? Yeah. Sorry. And you can see that the narrow optical blur basically drive the accommodation, and the fixation disparity drive the divergence. But here we have a chiasm in the middle. So this arm also influences the accommodation, and this one, divergence. So, and you know this is something that you really know. When we try to do a measurement with an Aberrometry, with an autoref, a typical ref with a device in front of the patient, we have that the device is perceived as near, and the fixation disparity is off, completely off. So you experience what is called the instrumental myopia. So basically, the far distance is affected by the actual proximity of the device. If you try to measure accommodation, it's even worse, because we don't have binocular vision, so no fixation disparity, and basically the accommodation is just partially triggered. So that's why in children, autoref and also Aberrometry doesn't work if you want to measure if you are willing to measure the myopia, the refractive status of the patient. And you already experienced this in your daily life. This is called divergence accommodation conflict. And the problem that we have to solve here for this device is to create a fixation system that mimics a real object in space at some real distance, such that divergence and accommodation are not in conflict. And how to solve this problem? Stop mimicking and just use real objects at a real distance. How? In this way. So this one is an open field Aberrometry. Okay, is going to have axial measurement as well for myopia control. And while the patient is looking through the real space, we are getting the Aberrometry. Having in this way PCR biometry, for sure, for the axial measurement, vision binocular while measuring. We don't have any device in this error because the patient is looking at the real space as in normal conditions, so without any influence of the device. And in this way, you are also able to perform accommodation measurement triggered by real precision disparity and real image blurring. Thank you.